we will find it's not just a biological process, it's a mathematical necessity. The emergence and evolution of life is a story of increasing complexity, a story written in the language of mathematics. Now let's turn to a seemingly mundane questions that can bring new perspectives. Are we the only life in the universe? For centuries, the search for extraterrestrial life has always captured our imagination. Now, thanks to assembly theory, we have a new tool for this exploration of space. Assembly theory. To detect alien life, it offers a unique approach. It's not by scanning the sky, search for radio signals, or analyze the spectrum to determine the presence of oxygen was possible. The complexity of molecules and structures that suggest the existence of life. Using assembly theory, analyzing atmospheric samples from distant exoplanet, or a sample of the surface of a moon in the solar system that suggests the existence of life, the higher the assembly index. And these molecules are produced by life's activities, the more likely it is not a random process. However, the path to the discovery of alien challenges and limitations, one of the biggest obstacles, is our understanding of life itself. Our definition of life is based on life on Earth. If extraterrestrial life, does it not meet our biochemical standards? Another problem is the vastness of the universe. The universe is so vast, and our current technology limits that exploration. Even with the most advanced telescopes, we can only analyze a very small part of the universe despite the power of assembly theory. But it's still in its infancy. It's a new approach. Its applications in the search for extraterrestrial life in uncharted territory, in an environment that is vastly different from its applicability and accuracy are in doubt. Despite these problems, assembly theory, the potential for finding extraterrestrial life remains huge. It may redefine our understanding of life in the universe, open new doors for astrobiology. So assembly theory looks at life offers a new way. It is no longer just a biological but as an emergent property of the complexity of the universe. Imagine what our planet looked like in the early days, a world full of sparks. The crucible of biochemistry. In this chaotic environment, simple molecules begin their journey of assembly. And that process is leads to something much deeper and chemistry. According to assembly theory, when these molecules reach a certain level of complexity, life happens. And this is where chemical memory comes into play. It's a crucial step in the evolution of life. Chemical memory, the ability to maintain the structure of certain molecular structures. In other words, this is the blueprint for life. In the world of assembly theory, replicability becomes key. To be able to replicate this is the simplest that drives life from the primordial soup. Our molecular evolution, and the dynamics of diversity that we've seen so far. During this evolutionary process, each step is an exponential increase. Suppose that at the core of the galaxy there is a great and invisible control its existence. This hidden behind the scenes is no other. It's a supermassive black hole, although they are often portrayed as a monster that devours everything. But this giant in the life cycle of the galaxy, at the center of most large supermassive black hole, is extremely attractive force. Not even light can escape. But they do a lot more than absorb matter. They're like the heart and lungs of the galaxy, in a way that we're only just beginning to understand. Life into celestial environments. Recent studies have shown that, from the poles of a supermassive black hole, ejected gases and radiation just are like the air that keeps us alive. The shock waves generated by this jet vibrates like the diaphragm in our chest. The movement of the diaphragm causes our lungs to expand. This respiratory system helps regulate the growth of galaxies, ensuring the delicate balance of the simulation. Shows the heart and lungs of a galaxy, and gas and streams from the central supermassive black hole. How to extend the lifespan of supermassive black holes? It doesn't act as a regulator for the galaxy, the universe will be teeming with zombie huge clusters of dying stars. Shock waves generated by black hole jets prevent it from cooling and condensing into thereby inhibiting star formation. This process can seem destructive, but for maintaining the health and longevity of galaxies. Today we will attempt to understanding the mysterious nature of supermassive black holes, their profound impact on the universe. In the end, we will realize, even in the darkest corners of the universe, there is also a heartbeat. It connects us all together. To fully understand the impact of black holes, we need to understand the types of and some key findings. There are two main ways a black hole can form. The most common way, linked to the death of massive stars. When a star is about 8到10 times the mass of the Sun, when it runs out of nuclear fuel, there will be a catastrophic explosion and supernova explosions. The core of the star collapses under its own attractive stellar black hole. This black hole is usually several times the mass of the Sun. It's the direct collapse of a massive gas cloud. This process keeps the star formation stage entirely. Can form masses from thousands to hundreds solar masses of times. People think this direct collapse occurred in the series of the supermassive black holes. With the concept of black holes was first introduced predicted in 1915. It acts as an exact solution of a general relativity equation described as the equation of space-time for Schwarzschild's solution allows us to discover regions. In these regions, very attractive force. Nothing, not even life. The first telescope confirmed by observation. Cygnus was discovered in 1906. This stellar black hole in our galaxy, through accretion of companion material, generated X-ray radiation. Identified. The discovery is that black holes are not just theoretical ideas. They're objects that are real in the universe. The first strong evidence of scientists have determined that a black hole is mainly composed of three regions: event world, photon balls, and singularity. The event world is one. Nothing can escape crossed. And just beyond the event horizon, the attractive forces here are very strong. Light particles are forced to orbit here. In the center is the starting of infinite density. The laws of physics as we know them. Failure at this point. Black holes come in all different sizes. Stellar black holes are formed by collapsing several times the mass of the black holes located at the centers of most galaxies. Mass ranges from millions to billions of times. The Sun has different intermediate mass black holes. Something in between 110万 times the mass of the Sun. In 2019, the World Telescope Cooperation Organization, the first image of a black hole in historic photo. You can see it. Shadow of a black hole against a luminous accretion disk. This observation for the theory of black holes provides direct visual evidence to study these mysterious objects. It opens up new possibilities. The latest news about black holes. One of the most common and controversial issues is, according to Stephen Hawking's theory, black holes can be detected by a method called the process of radiation. Slowly evaporates over a long period of time. When pairs of particles form near the world, a particle falls into a black hole, another particle flies away. For a very long time, these streams of ejected are lost in black holes. Final evaporation. Although black holes are often depicted in science fiction, are not indiscriminately suck everything around. To be captured by a black hole, objects must be very close to the event horizon. In addition, these black holes suggest potential wormholes or access to other places. But these ideas are still just speculation. Observational data. Scientists estimate that the Milky Way alone contains more than 100 million black holes. Understanding the basics of black holes, including the way they are formed and the different types, to study their understanding of galaxies. the profound impact of the entire universe. Lay a solid foundation. So even though supermassive black holes are invisible, but their existence, you can learn about your surroundings through an attractive force field. But how did these massive celestial bodies form? What are their distinguishing features? Well, in theory, when a large amount of matter, when compressed into an extremely tiny space, an attractive force field, so powerful that nothing can escape, and that gave birth to black holes. This was once considered too bizarre, and is not real. It has now become an accepted fact. Black holes, especially supermassive black holes, are all over the universe, millions of times the mass of the sun, or billions of times due to the attractive force on nearby stars, and was detected. The speed at which these stars orbit the black hole, the speed of orbiting an ordinary object of similar size, much faster. By measuring these orbital velocities, astronomers can estimate the mass of a black hole. For example, Sagittarius, a star at the center of our galaxy, its mass is about a semi-million times that of the sun. Some supermassive black holes, even more than a Sagittarius star. In the dwarf galaxy Leo, there is one. A black hole about a semi-million times the mass of the sun. In the neighboring elliptical galaxy, there's another one. A black hole with a mass up to 55 million times the mass of the sun is a black hole in the Able Ardo-E star cluster. It is estimated to be about 8 billion times the mass of the sun. Location has not yet been determined. These black holes, especially black holes in active galaxies, they were surrounded by a rapidly rotating gas, and accretion disk of dust can release a lot of energy, sometimes even brighter than the entire galaxy. This process took place in 2019. Wonderful capture by the World Telescope. At that time, he photographed in the galaxy Amidst the accretion disk around a supermassive black hole, revealed a black hole 6.50 billion times the mass of the sun. The formation of these supermassive black holes is the subject of intense research and speculation. Science fiction stories. Real black holes attract matter through attractive forces rather than actively smoking. This attractive force is especially at a distant close range. Its function is like the same attractive force as any other object of similar mass. The oldest supermassive black hole, almost massive gas containing millions of stars, immediately formed when the attractive force collapses. This direct collapse model shows that such a black hole may have formed in just a split second on cosmic timescales. According to another hypothesis, under the extreme conditions of the Big Bang, primordial black hole became the seeds for subsequent black hole growth. This massive celestial body can go deeper. The fundamental processes that shape galaxies to understand the entire universe. But what happens when two galaxies collide? This is more than just a dramatic cosmic event of changing the structure of the universe. At the center of this galaxy collisions is also supermassive black hole. Their interaction produced some of the most galaxies not close to each other. The supermassive black hole at their center, starting to produce the interaction gradually spiral closer. The inevitable merger, and it doesn't happen quietly. It brings a lot of surrounding gas and dust. It's a turbulent environment. It's the conditions of the emergence of all kinds of processes simulated. It was found that when they can generate extremely powerful electromagnetic radiation, and this just come out along the axis just rotatingly observed around as much more black holes. Before the black holes merge completely, the cosmic show has already begun, provided by this astronomer. Potential early warning of these events, and change the ionization state of the atmosphere. The relationship between supernova and gamma complex and engaging. In some cases, collapse of the cores can trigger gamma ray bursts. especially when stars are rotating and with a strong magnetic field. This long gamma ray burst is often accompanied by a 2-second word gamma ray burst. Not only is it striking for its brightness, it also provides clues for studying the formation of heavy elements. Scientists conducted a detailed study of the eruption. He was responsible for the origin of elements heavier than iron. Provide clues. These elements are typically found in supernova explosion of neutrons. However, further analysis revealed that gamma ray bursts do not produce this. Further confuses. It also highlights the mystery of this cosmic phenomenon. To understand the true cause of this outbreak, scientists have used space telescopes including James Webb, a variety of observation tools. The anomalous brightness of this burst, it initially obscured its surroundings, makes observations of accompanying supernova or other objects in the host galaxy become difficult until a few months later. The brightness is reduced enough to make detailed observations. Result: a relatively imperceptible sporadic has been detected. The powerful energy of gamma ray bursts. This finding is surprising. Hotter gamma ray burst also gives us an idea of the characteristics of gamma ray bursts. The unusual brightness and long duration of this event shows that the energy of gamma ray bursts is directly concentrated. This narrow directionality could be responsible for the intense brightness observed. Gamma ray bursts tend to be directional phenomena. The narrow jet may have been caused by rapidly rotating stars with strong magnetic fields, caused by powerf3 and concentrated flares. Although burnt, gamma ray burst. To understand gamma ray bursts and supernova helped, but scientists are still struggling to find the depths and enigmatic answer. Recent studies have shown that the luminous change period of deep hues is part of its natural behavior as a variable star. It turns out, unlike the Sun, deep hues is an extremely unstable and low-density plasma shape changes a lot. A scientist's simulation shows the behavior of deep hues during brightness approximately every 7 days. The longer cycle is about 90 days. Recent research trying to explain the great dimming over the past few years. Observations from various telescopes provides a lot of insight, including microwave and infrared observations at different frequencies, allowing scientists to penetrate deep hues outer layer. Silicon monoxide detected. This suggests the existence of this discovery cloud overturned the original deep speculation that the contrary is about to explode. It seems that the activity inside the star causes the matter, although Sagittarius A is closer to its smaller size. The matter revolving around it moves very fast. It is difficult to obtain clear comparison. In the larger galaxy M87, matter moves slowly, easier to observe. Overcome these difficulties to compare the black holes at both ends of the mass range. Provides valuable data. Sagittarius, a star and magnetic field similarity, shows that if the central black hole of our galaxy are hidden jets, this would explain the behavior and evolution of black holes. Provide new insights. The observation of such a jet will be a major discovery. It puts Sagittarius, a star linked to the high energy processes that form galaxies. Found such a jet will be greatly expanded. We understand how black hole affects its surroundings. The understanding that jets can influence star formation and the overall evolution of galaxies. By comparing different black holes, astronomers will be able to determine the universal laws that govern these mysterious objects. Supermassive black holes allows us to integrate this abstract concept, connect with the familiar environment, bringing the distant universe closer together. The impact of supermassive black holes far beyond their attractive force. Relativistic jet has a huge impact on the formation and evolution of galaxies, from star formation to the distribution of gas and dust. Certainly not affected by it. A striking example of this is the Teacup Galaxy, billion light years from Earth. The Teacup Galaxy is named after its unique halo structure. This structure is composed of the supermassive light by relativistic jet activity. This galaxy vividly displays, even with low energy, jets can also have a significant impact even on radio quiet galaxies. Jets can also redistribute and disrupt surrounding galaxies' ability to form reasonings of the Atacama. Observations made by the Large Millimeter Array show that the jets in the Teacup Galaxy are relatively weak, but they can move, heating and accelerating gas in galaxies. Even in a set of quiet galaxies, jets can also redistribute and disrupt surrounding gases. This affects the galaxy's ability to form new stars. Astronomers at the Canary Institute for Astrophysics, Christina Ross later explained the impact of these jets is not always immediate. The study found that the most significant impact in the Teacup Galaxy direction perpendicular to the direction of the jet turbulence is caused by a shock wave generated by a jet of air bubbles. A gas heated and expanded by a shock wave. These interactions we can stop the gas cooling and collapsing into new stars to inhibit star formation, although the powerful can heat the gas in the galaxy to a certain extent. Therefore, it slows down its growth, stopping the formation of new stars. But weaker jets, as in jets in radio-quiet galaxies, also plays an important role. These jets can still stir up the gas in the galaxy and redistribute it. This kind of activity can lead to the formation of new structures within galaxies and influence its long-term evolution. Understanding the impact of these jets helps astronomers piece together the complex puzzle of galaxy formation. Supermassive black hole is an integral part of the life cycle of galaxies. Huge changes caused by strong jets to the more subtle ones produced by weak jets, but equally important. Stay tuned. Let's explore the forces that shape the universe. Our universe, hidden for a long time. The mysteries that have always fascinated the human mind. The issue of the divide between simplicity and complexity. Life is in a constant motion of order and chaos. Flourish. Every form of life of a hidden order is a model that fits from the smallest microbes to the largest is all the same. But if the complexity of life, the essence of our existence, and is not just explained through a biological lens, it can also be explained through a mathematical framework. That's the domain of assembly theory. It's a groundbreaking concept. It goes beyond traditional science. It's a journey into a world. In this world, mathematics and biology are intertwined. Reveal the hidden structure Imagine of the universe. In this universe, from the simplest molecules to the most complex of life is encoded in a mathematical language waiting to be decoded. In this universe, the line between living and non-living becomes blurred, enabling new possibilities and new understandings. Let's explore together this revolutionary idea. How has it changed our understanding of life, the evolution itself? Maybe we can even get closer. Answer the ultimate question. What is the true nature of life in the universe? Since the birth of civilization, mathematics has always been the language of the universe. It is a tool for deciphering the mysteries of nature, but this language of numbers and equations. What does it have to do with understanding the nature of life? The core of assembly theory. It makes a simple but profound point. The complexity of life. It can be measured and understood through a mathematical lens. Each piece of the puzzle represents a molecular building block. These puzzle pieces, how to put it together step by step structures that define living organisms. Every step of the assembly process both represent a leaping complexity from simple atoms to complex proteins. The theory introduced the concept this is the bedrock of the theory. It measures the steps that are required to build a biological quantity. This is a numerical value by quantifying things that are difficult to measure, capture the essence of complexity. But how does the standard model of physics fit into this? Describes the fundamental particles and forces that completely different from how complexity of assembly theory bridges this gap. In the field of assembly theory, standard model behavior to understand various forces and interactions. The foundation is the microscopic world of quarks and leptons. A bridge to the macroscopic world. Another important element of the theory to study the concept of dynamical systems is a mathematical concept used to describe all possible states of the system. In the context of assemblies, this allows us to start with a single point that represents expanding into space, branching into almost infinite possibilities. Every path both represent the different rules of the mathematical landscape. The path of evolution and its mathematical freedom provides us with an insight into the complexity of life, a new perspective. It's not just about the particles that the standard model describes together, it's also about how the interaction and interaction. Thus, it creates a rich variety of life patterns around us. It was here. Chaos of random molecular interactions which order in the fabric of life. So let's ask ourselves, the complexity of life is a mere accident, or is there something deeper? Let's consider two very different concepts. Complexity and damage quotient. Is a matter of disorder or random. It seems to be with us in life. Observe the complexity contradicts in nature. How do these opposing forces coexist? It was here. Assembly theory offered a revolutionary idea. The core of assembly theory is the assembly index. It's a revolutionary tool, only measuring the complexity of life. Think of it as a cosmic ruler. Measure from the simplest components. The steps required. Imagine a simple molecule as a starting point on a scale. As you move up the ruler, each step represents a more complex assembly, from molecules to cells to a more advanced structure. The higher the index, the more complex it is. The less likely it is that the structure formed by chance. Now let's dive into that. The interaction between injury and complexity. The concept of injury originated from the suggestion that systems naturally tend to be disordered. Life goes against this trend. From simple origins, gradually evolved into various forms, into the complex, orderly structures we see today. How is this apparent contradiction resolved? He thinks life is essentially a process of overcoming injuries. Through the perspective of assembly index, we can see the complexity of life is not a challenge to injury. It's moving forward through the Think about the early years. It was a primordial soup of simple molecules for thousands of years, driven by the laws of physics and chemistry. And these molecules began to assemble into more complex structures. Every step in the course of life, victory against injuries. Moving towards greater complexity, rethinking evolution from the perspective of assembly theory. A victory for the wounded. But the story of the origin and evolution of life. When these supermassive black holes finally merge, their jets will merge into a single high-energy burst. This could be accompanied by a less directional burst. Increases the probability of the merging process moves the surrounding plasma. Generating powerful jets. Theoretically, these jets can be observed billions of light years cosmic events is not only exciting, also under extreme conditions. Not just stories of increasing complexity, testing the limits of Einstein's general theory of relativity. Observations of this merger event, whether it enhances our current understanding or it reopens up new fields of physics, may lead to alternative theories. Future missions such as laser interferometric space antennas is expected to ability to locate these merger events. NASA is also a story of resilience trying and project to build a European space agency. It will orbit the Sun, mirroring the attractive force generated by this electromagnetic will be able to pinpoint and study these high-energy events in detail. Before these advanced instruments were put into use, astronomers rely on existing to detect electromagnetic jets. These jets, life is evolving from the depths of the ocean to the edge of space, provides a dynamic perspective on the evolution of galaxies, shows such a merger, how to dramatically change the structure and behavior of galaxies. Let's take a closer look at Sagittarius A. It's 4.30 million times the mass of the Sun. In the middle of spring this year, advanced observations with the help of this jet of our galaxy has revealed new secrets. Astronomers have recorded for the first time polarized light around the star in an extreme environment. This allows us to understand the magnetic field around the black hole. Offers a new perspective. Polarized light is crucial to understand the magnetic field of the light of gases and the mechanism that drives. And here's the interesting thing: the magnetic field around Sagittarius A is much more massive than the galaxy and the observed magnetic fields around are strikingly similar. Found a way to drive the black hole in Ambagi is 6.50 billion. This similarity suggests powerful and orderly magnetic fields. It may be a common feature of all black holes, no matter their size. The existence of such a magnetic field has Sagittarius may be hiding a jet. In other black holes, these magnetic fields drive powerful flows of matter. Although Sagittarius A appears relatively calm, in the field of scientific discovery, the overlap of the similar structure of its magnetic field suggests there may be a faint jet that has no image in a black hole at the center of the Milky Way galaxy. In the black, there are strong vortices and orderly magnetic fields. The co-authors of the study, NASA. Every new theory is scrutinized and debated. Hubble Scholarship Program recipients, Harvard University, and the Smithsonian Fellow at the Center for Astrophysics, Selisa said, this magnetic field for black holes, interactions with the surrounding gases and substances. It is the event world telescope theory. This array of telescopes from around the world that made these groundbreaking observations possible by combining data from multiple telescopes. The end forms a virtual telescope the size of capturing black holes. This promise never to revolutionize our understanding of life and complexity understanding. The concept is now at a crossroads. Received as Hector, critics such as Dr. Criticism from Zeno. Future development of assembly theory. It raises fundamental questions. This article is even 8000 hours long. It takes about an hour or two of concentration. Reading time. This is not just a taste of the subject, it's a deep dive into the heart of the scientific debate. Who are interested, we provide these two articles in the description, the study and its refutations. Looking to the future. The role of assembly theory in scientific research, still not sure. Can it adapt to and overcome these challenges? Become a footnote in the history of science, despite differences. But one thing is clear: The debate surrounding assemblies open the conversation about the nature of scientific in the pursuit of knowledge. Be transparent. The necessity of rigor and humility. The impact of final assembly theory may not lie in his specific claims. It is because he is in the scientific process, and that's what it taught us. In the process of exploring the mysteries of life in the universe, such theories will continue to emerge and change, but the pursuit of understanding, the quest to unravel the mysteries of our existence, will always be a core focus of scientific research. Supernova is not just a cosmic amazing event. They is an important cosmic phenomenon that shapes and creates a galaxy at the end of the life cycle of a massive star, ejecting various elements into space. New star planet. Even life itself is made of these elements. Essentially, supernovae are destroyers of galaxies. I'm a maker. In the study of supernova, images are essential for understanding these crucial explosions. Advances in imaging technology astronomers to capture supernova, spectacular sets at different stages, revealing the intricate details of this structure. An element ejected into space. The story of the red supergiant star is an image. How to help us understand supernova behavior. A typical example of Shanchu Temple. Recently, due to its sudden dimming, is getting a lot of attention. This change in brightness, sparking speculation that it was about to explode, attracted a lot of attention. Observed and photographed in telescopes, the dust cloud surrounding the star. It was originally thought to be a precursor to supernova explosions. However, later people began to believe correct. A natural phenomenon in the life cycle of a supergiant star. Initially, this star, could it be the next supernova to be a supergiant star, occupies a prominent position in the constellation Orion, located on its shoulders. It can be seen even with the naked eye. Let's take a look at the life course of Shanchu Temple. It's been a fascinating journey. It shows the star from its birth to the present day. As a person approaching the end of life, the evolutionary process of Shanchu was originally a massive star. Like many other stars, it bursts up in the Milky Way due to its massive mass. It's evolving very quickly, entered a continuous phase of nuclear fusion. The immense mass of this star make it evolve. Unlike low-mass stars like the Sun is currently a stable main sequence star, slowly converts hydrogen to helium. Battle gas is much more massive, exhausted the reserve fast, evolved into a red supergiant. The key differences between battle gas and the Sun is in their mass. The mass of deep hills is about subjected to higher pressure and intense nuclear fusion, causes deeps to burn its fuel rapidly. And that leads to unstable structures and remarkable brightness fluctuations. In comparison, the lower mass of the Sun make it possible over billions of years keep it stable. The hydrogen combustion stage is longer and more stable. As deep hills ages, it enters a continuous phase of nuclear fusion. Internal pressure causes stars to expand from main sequence star to red supergiant. This stage is characterized by changes in size and brightness. As as the star goes through a complex nuclear process. It expands and contracts. Recent observations suggest that Shansu may be on the verge of a supernova explosion in 2019, the star's dimming, and that it brightens up unexpectedly. This led scientists to speculate it may be approaching the final stages of its brightness. Changes are thought to be related to the beginning of collapse. Scientists analyzed the star for 130 day, 420 day and 2200 deposition cycle to understand its internal dynamics. The longest of these, the 2200, it may represent the basic particular of Shansu indicates that it is in this stage of evolution. These observations and recent telescope discoveries suggest that carbon burning stage before a supernova nuclear process determines the life of a star must come to an end. At the center of massive stars like Shansu, nuclear fusion converts hydrogen into helium minus energy. As stars age, heavier and heavier elements are fusing, deform structures like layers of an onion. Eventually the core is filled with an iron can release energy during fusion, which causes the attractive force to collapse. When the core collapses, can cause a runaway reaction in the process. The iron core collapses under a huge attractive temperatures force reach at least degrees. Rebound effect, core expansion, then it explodes. The resulting shock with top star explosions release tremendous amounts of eclipses the entire galaxy. The mechanism of this process involves nuclear collapse, the complex interaction between attractive forces and intense shock wave from the core collapse propagates outward, ejecting the outer layers of stars into space. Astronomers have recorded this bright phenomena. They are sometimes described as nemesis or planets. The earliest recorded supernova observation back to 1800. At that time, observing these nemesis were visible for bombing, although supernovae are rare. But astronomers are still studying them today, especially when they cause things like gamma ray bursts. When something unusual occurs, gamma ray bursts are intense. Gamma ray burst, usually associated with the collapse of massive explosions, are the most powerful in the universe. One of the most dramatic events, able to do it in just a few seconds. Release. Then the sun releases in its billion-year lifetime more energy. Third gamma ray burst discovered in October 2022. Also known as the brightest gamma ray burst ever observation of gamma ray bursts, is unprecedented and amazing impact on the planet, shocked astronomers. Burst gamma ray burst is officially designated detected it originating from a galaxy about 140 billion light years from Earth. This event is not only abnormal, it lasted a long time. It lasted about much longer than the typical gamma ray energy of this explosion is very affected the atmosphere, disrupting radio communications, formed a huge cloud of gas. Beneath this cloud, the resulting cold stone causes particles to condense and creates a dark cloud, blocking the view of Shansu Temple from the Earth. Further research on the behavior of Shansu Temple shows that the star experienced two shock waves, one in 2018, another one a year later. These shock waves disrupt the surface of the star. It creates hot spots and cold spots. This phenomenon got the Hubble Space Telescope confirmation of ultraviolet imaging observations. These shock waves and their subsequent effects overturned their original belief that battle got the hypothesis of a closed supernova explosion. It shows this behavior is part of the star's natural life cycle. Diffuse behavior also reflected in its high rotational speed. Unlike the typical slow-spinning red supergiant, Hughes rotates at about 3 meters per second. This initially led researchers to believe that it could be two colliding binary stars. However, recent studies have shown that this rotational speed may be affected by the interior of a star fast-moving convective cells. This contradicts initial assumptions about its rotational behavior, although Deep Hill's behavior was unusual. But this study shows that, in our lifetime, it's not likely to go supernova. The current state of the star, more like a red star near the end of its life. Supergiants, but nowhere near supernova explosions. Then finally, let's explore is a question that affects all of us. Such an explosion will harm our home. What impact does the planet have? The potential impact of nearby supernova on Earth is a subject of speculation and concern. Although supernova explosion, it is not expected to pose a direct threat to our homeland. But exploding stars within a few light years of Earth may affect the Earth's atmosphere and could have an impact on life. For example, also burnt gamma ray burst flares are very powerful. It significantly affected the ionosphere, altered the atmospheric conditions, interfered with radio communications. The explosion released a tremendous amount of energy. Interaction with the Earth's atmosphere causes a sudden increase in ionization. This increased ionization affects the ozone layer, and it has triggered scientists who are still working chemical reaction. Gamma ray bursts also interfere with radio signals, in particular, signals used for communication, and the energy released by the explosion is so great it blinded several satellites. This shows the tremendous power of this cosmic phenomena. However, this burst was light years older than 13 billion Earth observed in the galaxy. This incident highlights further research into gamma, the necessity of a radiation burst in order to understand their impact on us and the impact of the entire universe. In addition, supernova research also helps us understand dark matter, dark energy, and the overall structure of the universe. A type is supernova that occurs in a binary system. For measuring cosmic distances and studying the expansion of the universe is crucial. These standard candles helped astronomers discover the accelerating expansion of the universe, and that provides the context for understanding dark energy. Supernova are the focus of future astronomical research. Their explosive nature and transformative impact continues to fascinate scientists and inspire new discoveries. When some people broadcast live on the internet while eagerly anticipating the explosion of we look forward, like Villa Rubin Observatory and the European Space Agency's Euclid Telescope and other tasks can lead to new discoveries. These will help advance our understanding of supernova. As our exploration of the universe continues, these stellar explosions will undoubtedly shape our understanding of and our awareness of our place in it.